Welcome, everybody. If this is your first office hours, I'm Catherine. I am the student advisor for the data science career track.
I'm Molly, and I'm the student advisor for the rest of the courses in this group. You do DSCP.
I do data science career track prep, yes.
Yeah. Welcome. Yeah, thanks so much for joining us today. And I know we have a special
guest mentor. But Ram and Mohammad, want to introduce yourselves real quick?
Thanks, Catherine. Thanks, Molly. This is Mohammad Zakaria. I work. I'm a mentor at the introductory data science course. Ram.
Thanks so much, Mohammad. And yes, I am a mentor too. I live on the opposite coast. Mohammad lives in the East Coast, almost the East Coast. Yep. And I'm a West Coast guy. So that's it. I mean, short and sweet.
Awesome. And then we have our mentor guest, Matt Kent, who our host will be interviewing. So Matt, if you'd like to say hello.
Hey everyone, yeah, I'm Matt. I've been mentoring at Springboard for a few years now, and do some other work on the side.
Cool, thanks for joining us, Matt.
Yeah, thank you.
Cool. So Ram and Mohammad, if you guys want to kick it off with a couple of questions for Matt, and then anybody can also ask questions.
Oh, so Matt, are you actually like giving some presentation or talking about yourself, or we can just make it question driven?
Just
question driven works for me.
All right, let's just, the opening salvo would be, tell us a little bit more about yourself and how did you end up in the exciting role of a data scientist?
Yeah, that sounds good. So currently I'm an analyst at a healthcare consulting firm called Genesis Research. So we work with, various life science clients, kind of supporting their, analytical work. So, a lot of it is kind of processing, kind of patient level healthcare data to eventually publish research papers. And I kind of got here from an undergrad. I had a bioengineering degree, so not much programming experience, more biology, math background. And at a school, I sort of joined Memorial Sloan Kettering, which is a large cancer institution in New York City. And from there, I worked in their epidemiology and biostatistics department. So that's really where I picked up a lot of my kind of data science skills, learned a lot of statistics, a lot of R programming. And from there, kind of moved on to kind of my consulting role right now.
Cool.
All right. And then you usually doing your work with R or Python, since you mentioned that this is where you picked up your R skills?
Python.
Yeah, so day to day I work mostly in R, but depending on the task, I do work with Python as well. I'm not kind of one of those people that think one's better than the other. I think for me personally, I look at kind of what problem is at hand and pick the tool that sort of fits that the best. So sometimes it's working only in SQL, sometimes it's R, sometimes it's working just in the terminal. So it really depends on what task is at hand is kind of the tool that I pick. But yeah, day to day I work mostly in R.
All right. I see Ram smiling there because you mentioned Python. Go ahead, Ram, if you have a few questions for Matt.
I can see, Matt, that we don't see eye to eye on the use of languages, but that's fine. That's just kidding. So I loved what you're doing. And so can you tell us a little bit more of the kind of, transition that you went through when you came into, full-fledged data analytics role? So I kind of am assuming that in your previous avatar at the Memorial Sloan Kettering, MSKCC, you said you learned a lot of the skills, right? So and after coming into this field, working for profits, and MSKCC is a nonprofit. So what do you see any differences, or do you see similarities? Can you elaborate on that?
Yeah, so I think the interesting thing about the data science field is that there's definitely a lot of similarities between kind of companies like this. Staying, especially if you, for me, staying within the healthcare field, a lot of the work is similar. I think the bigger difference, starting for me at least, I recommend to a lot of students that I work with, is really when you're starting out, it's really looking to join kind of a team that is really going to invest in kind of training you and helping you and really want to work with you. So I think that's where I gained from the nonprofit side, working at an academic institution. A lot of the people were really invested in kind of helping myself and my teammates grow. And I think as you transition, into kind of for-profit companies that are, a little more concerned about business growth, they're a little less inclined to kind of spend time helping you grow. So I think, one of the things that was extremely helpful in my career was really, starting out in a position that I was working with people that were excited to kind of help me grow.
So Matt, can you walk us through what does a typical day look like for somebody in your position and skill set at your organization?
Yeah. So I guess the first thing I would say is that there is no typical day. Day to day, depending on kind of the projects I'm working on, it really varies. But I would say 75% of the time will be kind of working, with data. It'll be kind of programming. So, either writing SQL to kind of pull out kind of the data that's needed for an analysis, or writing kind of R, Python code to kind of process that data, clean it up, get it into a form that you can kind of run whatever the final analysis is. Then the last part of that would be kind of, writing code to run the analysis on top of this kind of process data, and then sort of writing up the results. The other 25% of the time will be kind of working with clients to kind of communicate those results back to them, kind of explaining what was done, kind of there were any assumptions being made around how the data were pulled or processed.
Like the cadence of your project as a consultant, is it what's a typical time frame for a project for you?
Yeah, so they kind of run anywhere. Some clients will want projects back in a few days, and some are longer projects. Some of the projects we work with have to go through the FDA, so those will take anywhere from 3 to 6 months. And some of those projects will have multiple programmers on them. So you might also be collaborating. I've worked in R and I collaborate with people who are writing in Python or SAS, and then when there's differences in our results, we kind of have to sit through the code or the differences in the data and figure out kind of why we're coming to different results. So those projects take a lot longer.
That's interesting. Is there like a current theme you're seeing in the healthcare industry about their requirements from from data science projects, and how do they perceive you can help them usually?
So a lot of it is really kind of from the analysis and report building side. So I think, what I've seen is the transition in healthcare is, a lot of people coming from, a statistics background will work mostly in kind of SAS or Stata or SPSS. But a lot of that is transitioning more into R and Python now because of kind of the ease of creating visualizations, creating kind of nice reports, and also the reproducibility of kind of these tools. So if you're working with patient data, if you're going to update the data, you kind of want your results to always be the same. So you can kind of set up these pipelines very easily with R and Python to kind of, input different data. Maybe there's more patients you have now, and kind of your results, will come out the same because you kind of have this workflow set up.
So did you have to learn also some SAS while you're filling this role?
A little bit. I try to stay away from SAS if I can. But a lot of people I work with kind of, they love SAS and they're kind of the opposite. They stay away from R or Python. So again, it comes back to kind of whatever you're comfortable with to kind of get the job done. Tends to be the most important.
All right. West Coast, do you have any questions?
East Coast to West Coast. Yeah. So, it's really interesting because, I come from the same background. So I was principal data scientist at Fred Hutchinson Cancer Research Center before moving to a company. So I was just wondering, so when you present, data science or data analysis based results to an audience, like your, clients, say, how do they take it? So, because I know that people who come from a biomedical kind of a background, they tend to not believe too much of statistical stuff, saying that, okay, this is just a correlation and it's not a causation. And so do they kind of, at the Hutch, they kept demanding that, we pair this with, experiments or stuff to actually prove causation. So what has been your experience with clients actually, when you actually, talk about correlations and finding significant p-values, say across two different conditions or something. So what has been your experience dealing with clients when you are talking with data?
Yeah, it's always tricky. I work with a lot of kind of surgeons and doctors. Whenever they have a research project, they always kind of, have an answer already before you even start analyzing the data. So if you ever come back to them and the results are kind of different from what they're expecting, they always think there's something wrong in the analysis, or, you coded it wrong, or the data is wrong, or something like that.
Or maybe math is wrong.
Yeah. So I find it just very important to kind of, at all the steps where you start from kind of your raw data, going through sort of the EDA process, create, clear visualizations that kind of, people can look at and sort of understand, this is how you're getting from just raw, files of data to kind of your final results. So they can kind of see that path, and not just presenting, that we have 1,000 patients and the p-value for this model is this, but actually kind of showing, what the transition from start to finish is. And I also find it, sometimes having an example that you can always go to that's unrelated to the fields you're working in. So I'm a part-time runner. So whenever I'm explaining kind of regression models, I'll tend to kind of go back to a running model, and sort of everyone can understand, if you run kind of a half marathon, you have some time, that might be your outcome. And then you can adjust your time for different factors, as maybe the type of sneakers you wear, or, your gender, what the weather is, things like that, and sort of explain modeling in that context, and you kind of pull it out of the context of the field you're working in. And I found that to help a lot as well.
It's a very good example.
Yeah.
Just a reminder to fellow students and attendees, like, this is an open platform. Just feel free, if you have a question, you may, unmute yourself and ask a question, which would be great. Or feel free also to type in the chat, and we'll read it to our guest, Matt. So Matt, what sort of advice you can give, what sort of wisdom you acquired throughout your career now in data science that you wish to convey to our students and mentees?
Yeah, definitely. So I think it's important to kind of find kind of specific topics or problems that you're interested in. So I think the data science field right now, there's so much out there that you could, potentially learn from, just simply technical skills, in different fields. You can learn about visualization, you can learn about model building, you can learn about image processing. There's so many different aspects of kind of the data science field in general. And I think eventually the field is definitely going to kind of split a bit more, and people are going to be more focused on individual topics. And I think that's kind of a good way to kind of, specialize yourself, look for a field that you're interested in, if that's healthcare, if that's finance, figure out what a company you might want to work for is looking for, and then kind of focus on those skills, and kind of learn, technical skills based on kind of problems that you want to solve. So don't kind of, potentially just go pick up a technical book, but figure out what problem you want to solve, and then find the technical tools that'll help you solve that problem. I think, would be extremely helpful when you're starting out. It's just something that I did when I started out as well.
All right. So it's a problem-driven approach.
It's a neat response, actually. And I think we have a question in the chat box that I see.
Go for it, Ram.
Yeah, cool. Thank you. So I think Sheila is asking, are you using more unsupervised learning models or supervised learning models? So which one do you find more useful to your problems?
Yeah, so for probably 99% of the problems I've ever faced in cancer research have been supervised models. Publishing research papers about patient information, kind of, what factors are, say, associated with kind of cancer. You really need to be able to explain those models. You really need to know kind of, if you take the classic example of lung cancer and smoking, you really need to be able to kind of evaluate, how strong the association between, some variable you have, whether it's smoking or something else, and sort of your outcome of interest. So, most of the times in the healthcare field, it's really regression models and survival models. I would say survival models, kind of Cox proportional hazard models, that really kind of trump everything, because you're really always looking for these time dependent outcomes. survival, recurrence, things like that.
And I think Alex has another question. Mohammed, can I give you the baton?
Go ahead.
So I think for Matt, I think Alex is asking what they are looking for normal distribution for probability. So I didn't quite get that question. So does he, Alex, I mean, did you mean that is Matt assuming a normal distribution for his data while calculating the p-values? Is that what you're asking, Alex? I just want to make sure that we ferry across your question clearly. Can I request Alex to, so if that was the question, Matt, what would be your response?
Yeah, I would say, I mean, in general, the assumption for most of the models is a normal distribution. I think that's pretty standard, at least for, things like regression modeling. So yeah, I mean, I think the underlying assumption for most of the data we work with is that it's normal. I mean, you can sort of investigate that as well by, plotting your outcomes or your covariates out. But I would say, yeah, the underlying assumption is usually normal.
So you're mostly using like things from the parametric world.
Yeah.
Cool. Okay.
Matt, a lot of my students would ask advice saying, like, I'm interested in joining data science in the medical field, for instance, and where is there like a region or a hub that they should be like directing their attention towards that? Or is it distributed geographically, on some sort of equal footing?
Yeah, so depending on the type of healthcare, I would definitely look for kind of the big cancer institutions are definitely always big hubs. So I'm based in New York City, so, Memorial Sloan Kettering is here, Cornell is here, NYU is here. If you move, Seattle has Fred Hutch. There's MD Anderson, there's the Mayo Clinic. So I think around those kind of big centers, typically, I guess, big cities have kind of big medical centers. So they would definitely be good places to start. I think also looking for, if you're starting out, looking for kind of academic medical institutions that have, they're looking to actually train people. So that's kind of MSK, sort of an academic cancer institution. So they were really interested, on their side is research and training people, whether that's doctors, surgeons, or, people doing research for them. So they're heavily invested in kind of that learning side to their work.
All right, that's a pretty good question. That's a pretty good answer. I appreciate that. Neil has a nice question. You want to go for it, Ram?
Okay. So Neil is asking, right now my code is very basic for my project, and I have seen some example projects of other people. I feel overwhelmed and think I can't do those things or don't have the knowledge. So when you started, I think he's meaning you, Matt, did you feel this, and how did you overcome this?
Yeah, that's definitely a normal feeling when you're starting out. I felt that. I still feel that every now and then. But I think there tends to be, you should definitely realize there also tends to be kind of a bias in what you see, people publishing. So similar to kind of any kind of website that has reviews, there's always some bias to someone having some interest in publishing something they're working on. So you don't see kind of all the other work that people might have worked on that they didn't want to publish to people, and they're sitting in kind of private GitHub repositories that will never see the light of day. So definitely keep that in mind. And also, starting out, it's really you're kind of just trying to learn what you're interested in and kind of what you want to work on. So definitely just pick, again, would definitely focus on a few kind of specific problems that are interesting to you, and then just kind of build up skills from there. So maybe you want to just focus on visualizations to start. So, whatever language you're working in, just learn how to kind of build more and more exciting visualizations, and then go from there. You don't always have to focus on kind of every aspect of kind of a data science project. So don't worry about kind of having to create a lot of visualizations and also have to do modeling all in one project. Pick kind of the certain part of maybe the data science process that you're interested in the most, and kind of learn that and kind of build out from there.
I completely agree with that, Matt. And also, Ram probably appreciates it. Even
Yes,
if you
I did. Yeah.
even if you spend a few years in the field, you can still see things that's like, wow, this is just amazing.
Yeah.
And like spending some time to learning new code, new ways to do things, or even better ways to do all things is just it's a sign of improvement and growth mentality, and it's very rewarding. So
Yes, especially in Python. Yeah.
yeah, and yeah, of course. And so if you're a beginner, it's absolutely normal. Even if you're a seasoned data scientist, you always find something that is amazing in this field. It's a very exciting field, and it's just mushrooming nowadays.
Yeah.
Next question is from Sheila. She's asking, which are your go-to model evaluation metrics? Precision or recall, for instance?
Yeah, so I focus mostly on discrimination and calibration. So discrimination is typically kind of your area under the curve. And that kind of gives you a way that sort of ranks predictions against each other. So, did someone with a positive prediction, have a higher probability than someone with a negative outcome. And then calibration, you'll sometimes see as kind of plots against what sort of a perfect model would look like. So you're kind of plotting sensitivity against specificity. So those are kind of the two metrics that I tend to use. And precision and recall kind of play into those as well. You kind of have your matrix of kind of your true positives against your false positives. So they're all kind of lumped in. But I would say AUC, you'll see, especially in the medical field, you'll see AUC kind of discrimination and calibration reported the most.
So it's basically different, like you're manipulating the four confusion matrix elements in a different way. That's all.
Yeah. So I'd say probably at night, or at least almost all the kind of model evaluation metrics I've seen are just various manipulations on those kind of four values.
That's pretty cool. Let's see. The like you said, like working in the medical field, is there anything like unique in that versus other industries that you would that you would caution or advise somebody trying to switch fields?
There's definitely a lot of exciting work going on, in terms of, I've seen, a lot of people working on kind of image recognition now. So if you're into that, I think the medical field is, really exciting in that aspect. I think, radiologists should be concerned because, being able to kind of detect cancers or things going on, in x-rays, is kind of like a perfect, kind of machine learning kind of task. I think the tricky part is how do you learn that outside of being in medicine? I think it's one of the harder sides because patient data, you can't really find it, openly in the public. So those kind of things, if you're interested in them, you kind of have to get into a hospital or into kind of a cancer center to kind of work with that type of data. Where other fields, you can tend to kind of work with types of data outside of kind of being a professional in the field.
Would it be easy for somebody to intern for a hospital, for instance, like say, hey, I'm an aspiring data scientist, I have a skill set, but can we do this, symbiotic relationship where I get access to your data, while doing a project during the summer, for instance?
Yeah, if hospitals are, there's definitely some research centers that are open to that. I've seen postings like that up. I think starting out, there are good places to go. I think once you have some skills, I think a lot of the data science skills are pretty transferable between fields. I think, kind of that domain knowledge will take time to pick up, but if you know your statistics, programming skills, those are, can transfer pretty well between different fields. And I think that's one of the nice parts of working in data science as well. If I wanted to move out of healthcare and move into finance, a lot of the work I've been doing in terms of model building, model evaluation will transfer into finance. I would just have to learn about kind of the finance data itself.
All right. So we have a couple of questions. Ram, you want to take a crack on them?
Cool. So, Alex is asking, are you looking for drugs and how they work? And by that, I think he means, have you, worked with things like drug target prediction stuff?
Yeah, so some of the projects that I work on definitely are, you know, we work with some pharmaceutical clients that are looking to kind of understand how their drugs are affecting patients in the real world. So this isn't necessarily clinical trials. It's really understanding kind of our patients having maybe adverse events that they're unaware of kind of in the real world situation. And I think that's most of the projects I've worked on so far in terms of drug evaluation, are really trying to understand, you know, how patients are being affected, how it's affecting their survival, you know, how it's affecting, you know, if we have questionnaire data that patients fill out, how it might be affecting their quality of life. And then that kind of gets reported back to these companies.
So your role is basically being integrated to like drug trials, for example, or like medical research prior to publishing results. So you help them actually hashing the data and working through it.
Yeah, so we're basically, you know, I'm almost embedded in some of these companies and work directly with their scientists.
Mm-hmm.
So their scientists will come up with, you know, some hypothesis that they want to work through. We'll kind of discuss sort of the best way to kind of analyze the data, if the project is even possible with the data that's available. Kind of write out the kind of statistical analysis plan for the project, and then kind of work through the analysis of that. You know, acquiring the data, you know, writing the code to analyze the data. Putting together the report that kind of summarizes all the findings, and then that sort of goes back to them. And then typically these either go into publications, so they'll get published in medical journals. Some will go on to conferences to be poster presentations. So it really kind of varies on what the end goal for kind of different clients are.
That's interesting that you would use, you know, like you would hire a company to help you go through this stuff. You guys don't get credit on the paper, do you?
Some of them we do.
Ah, that's interesting. I really didn't know that. Let's see. So we got a question from Neil. He was asking basically about your day-to-day activities as a data scientist. We touched on that previously, but if you feel like adding something, you know, he talked about meetings and talking to your managers and stakeholders. How much does that take of your time?
So currently, not a lot at all. In previous places I've worked, though, it took up a lot of time. You know, I think kind of meetings and stuff definitely vary by company. Some companies are very heavy on meetings. Other companies are not. Current company, you know, we have 1 or 2 meetings a week in terms of just to catch up, kind of work through kind of what's going on for the week. In terms of clients, typically it'll be 1 or 2 meetings up front and just to kind of hash out the details of the project. And then as we're in the middle, you know, they just kind of check in on when their results are going to be ready. So it's more just getting emails every other day saying, "Are the results ready?" But
I see that hit the jackpot in terms of work meeting balance. So good for you.
Yeah.
That is pretty remarkable. Ron, do you have any questions for Matt?
Maybe, I mean, the final question might be, at least from my side, would be, I mean, if you are looking to hire a young, new data scientist, what will you look for?
Let's not add age discrimination towards this. If you want to hire a junior data scientist, go for it.
Okay, thanks for correcting me. Yes, no discrimination. Unicorn, monster, everything is the same. Yes.
Yeah, so I tend to, you know, I've interviewed a lot of people for, you know, when I was working at Sloan and currently for positions, and you know, a lot of the time I'm just looking for someone who has, you know, generally has some sort of background, you know, working with data, some programming skills, and just overall, just, you know, kind of seems that, you know, they're smart and interested in kind of the work that they'd be getting involved with. I think the data science kind of field is really just being excited about working with the data that you're going to work with. I think if you're excited about working with the data that you work with, then kind of the programming aspect will become exciting. Understanding your results will become excited. You'll want to learn about new tools to kind of explore the data even further. So I think if you get into a field where you're not really excited about kind of working with the data, then kind of the programming will become boring. You're not going to be interested in learning, you know, new ways to analyze the data, or new tools, or building new models, things like that. So I think, you know, for me, you know, I think you can always learn new technical skills if you're smart. You know, don't worry about, you know, if you're not, you know, technically the strongest right now. You know, all of that takes time, and even as you learn new technical skills, there's always more to learn, especially in the technical side of things. In terms of domain expertise and statistics, that too, you know, you can always learn more. There's always a new model to learn. there's always more you can know about the math behind different prediction models. So as long as someone is really is smart, they're excited about what they're going to be working on. I think everything else you can learn kind of on the job.
Catherine, can we squeeze in one more question?
Yeah.
That's actually two. So I mean, we'll let Molly and Catherine, take up
Let's
the
power
task.
through them.
Yeah.
So basically, if you wanted to break down the time needed on average for a project, how would you break it down basically in terms of stages? Which stage takes more time? Which stage is more tedious?
Yeah, so the definitely, I mean, the data, I guess it's probably the most common response to questions like this. Definitely, I mean, the data cleaning, aggregation, all of that, definitely takes up the most amount of time. Building something like a regression model is typically, one line of code, but, just understanding what format your data needs to be in, do you have the right data, cleaning it, processing it, all of that really kind of takes the bulk of any kind of project's timeline. And then I think aside from that, you kind of, once you have results, whatever they're presented back, there's always going to be changes. So whenever you're working on a project, definitely try to structure your code and kind of your workflow around understanding that projects are usually never done. There's always going to be some change that's going to have to come up. And if you have to go back and spend a lot of time kind of tweaking your code to kind of change one thing here or there, it just makes the project even longer. So I think if you can structure your code where changes at the end are easy, then that becomes less of a time-consuming part. But the data cleaning and processing definitely takes the most time.
It's a good investment to spend some time on the documentation and making your code readable, even for you after a while. Last question is about actually being a data scientist while working remotely. So how likely is it to work remotely as a data scientist? That's from Jim.
So I think it's extremely likely. I think, in my past few roles, I've usually worked a few days remote. Some of the days where you just have to kind of, get through some data processing, write some data cleaning code. You don't necessarily need to be in an office to do that. I think, if you're better working at home or working, in a coffee shop where you can just focus on writing your code and focus on the data, create some visualizations, that can really be done anywhere. And that's also another good way to avoid meetings. So that's another trick. If you work remote, there's less likely to be called into a meeting or have someone kind of steal your time by coming up behind you and just chatting about something. So I think it's one of those positions that, definitely extremely likely to get some remote work.
Yeah, work flexibility is a great perk. My boss keeps telling me about working remotely. Sometimes I feel it doesn't want me in the office anymore. How about you, Ram?
I am 100% remote actually, except when I do ground teaching for Northeastern. So at my company and at the Gates Foundation, I'm 100% remote. So.
All right. Good for you. Oh, I think this is a good segue.
Awesome. Well, cool. Well, thank you so much, Matt, and thanks, Mohammad and Ram, for asking awesome questions and for everybody for joining. And Matt, it was really great to have you, and you're always welcome back for us to pick your brain in the future.
Awesome. Yeah, thanks a lot for having me.
And we appreciate the questions from everybody. Sorry, I interrupted you.
No, just saying thanks for having me. And yeah, if anyone has any other questions, feel free to find me on Springboard.
Thanks so much, Matt.
Cool.
All right.
Thanks so much, everyone. Molly, Catherine, Mohammad, and everyone who asked questions. Thanks so much. Have a fantastic day.
Thank you, guys. See you next week. Bye-bye.
Bye.
Bye.